Alright, today I will talk about the problem factorials. So in this problem, it's actually really simple if you know a secret formula to this. But otherwise, if you don't know this formula, you can use mathematical analysis to find out a formula for this last non-zero digit. And so here in my code, I'll show you the really useful formula. It's a recursive formula, and it's derived by other mathematicians, and the proof for this is really complicated. So if you want to know how this is proved, you can go check the link I posted in the descriptions. So this is a recursive formula. We will use this getLast function to get the last digit of our factorial, and this will require you to calculate the tens digit of this current number and the ones digit of the current number. So since we're dealing with tens digit as well, we have to first check if x is smaller than 10. If x is smaller than 10, then we of course don't have a tens digit. The tens digit is 0, so we will return one of the few base cases. And these arrays are just last non-zero digits for each of the factorials from 0 factorial to 9 factorial. I found these by typing them into the calculator, and then you'll get the last few non-zero digits. So if x is smaller than 10, we'll return that. Otherwise, we'll get the tens digit by dividing x by 10 and then modular by 10. So dividing by 10 will remove the first last digit of x. So that basically removes the ones digit, and now the tens digit is at the last place of the number. And now we modulate it by 10, which removes everything other than the last number. So we'll get the tens digit, and the ones digit is the same, modular by 10. We will this modular by 10 will remove all the numbers other than the last digit. And then we will have to check if the tens digit is odd or even. If it's odd, then we will return this formula, and it's quite complicated. You have to first multiply by 4 and then get the last digit of x divided by 5. This is all derived from the math, and as I said, it's really hard to prove right here. And you can multiply it by the base of our 1. So then we will multiply the last non-zero digit at the ones digit of x. So then we'll have to modulate this by 10 just in case we get a number that is greater than 10. And if the tens digit is even, we will multiply this by 6 instead, and still use the same thing, get last x divided by 5, and return and multiply that by the last non-zero digit for the ones digit of x, also multiply by 10. So after you read the input n, all you need to do is just print out the get last n. So this will cause this whole thing to go through a recursion, and we'll just keep on going up until we've reached x is smaller than 10. And they also have an explanation for the analysis on this website, on the USACO website. You can also check that out. It's that one talks about counting 2s and 5s, because you can try to figure that on yourself if you have extra time, because when you have 2 and 5 entering a factorial, they'll always multiply, and there will always be more even numbers, more factors of 2 than factors of 5. So whenever they multiply, they will form an extra 0 after the digit, and so it involves something around that. But for my code here, I will only explain this recursive formula. So it's good that it will be nice for you to memorize this formula, because it might become useful in future places.